In the last video, we have tested our smart contract, single swap smart contract, and connected with the front end, and we did the swap. In this video, we're going to write the smart contract for liquidity, and that's the contract is one of the most important contract when it's come to decentralized exchange, because you have to know how to provide liquidity so anybody can add their token as a liquidity, so anybody can come and purchase and do the swap. And that's the contract we're going to build right now. So here we are back into the project. Let me open the contract, and inside that I'm going to create a file. I'm going to call it liquidity because that's the contract we're going to write. So that's the contract we have. Let's come here, and now let's start writing the smart contract. So we're going to follow the same old school. We have to provide the license identifier, SPDX license identifier, GPL2, and this. Then we have to define the Solidity version. We're going to take this one. We have to provide the Pragma ABI encoder, so we can do the struct. We can use struct and arrays, nested array. Now we have to import couple of packages. So we need to UB core contract interface Uniswap v3 pool. Now we have to install the Uniswap v3 core contract library. Take math.sol. We have to import this OpenZeppelin contract token ERC21 ERC receiver.sol, and we have a Uniswap v3 periphery contract library transfer helper.sol. We have Uniswap v3 periphery contract interface if in non-fungible position manager.sol. Uniswap v3 periphery contract balance liquidity management import hardcode console. So these are the important packages which we're going to use in this Liquidity smart contract. So you can see that we are using OpenZeppelin, we are using Uniswap v3 core, we are using Uniswap v3 periphery. All these tools are really powerful, and without these you can't able to create your Liquidity smart contract. So we are using OpenZeppelin, and this package is really very important, and that's what we're going to use it to create the instance of our liquidity. So everything will make sense. So make sure you have to type the exact one. You have to use this variable. Okay, so let's continue. So let's come here. We're going to define the contract. We'll call it liquidity example is, and we are going to inherit the property. So we're going to inherit this ERC721 receiver. That's the contract we have, and I'm getting this error message because currently I'm testing an extension which we have developed. So that's why you can see that I haven't done any configuration, so that's why I'm getting this error message. But let's complete the smart contract. After that I'm going to fix it. So let's take a variable, say address public constant die. So this is the die token contract address which I have got from the mainnet, which you will find in the descriptions. Sorry, starter file. Now we'll take another one constant, and this is going to be USDC. We'll have to provide the address of the contract. Now we're going to come here. We're going to define that fee we want to charge whenever someone will do the swap. So we're going to take 0.01% fee. You can take it 0.03%, or you can take it 1%. But in most of the exchange you will find that this is the range. Generally the liquidity providers takes 1 to 3. Now let's come here. We have to define that UNT public constant pool fee is going to be this 100. And the reason why I have defined constant, because I'm not going to change this pool fee, although you can, but when you have to change this pool fee, on that time you don't need to define this word constant. So we have our pool fee, sorry. Now we have to take this non-fungible position manager, and this will allow us to create the liquidity. So we need to have it. So we'll say public non-fungible position manager, and in that we have to define the address. So we'll say non-fungible position manager, and in that we're going to type the contract address. So right now I'm going with this hardcode value, or if you want you can pass this same thing in the constructor at the time of deployment, and you can update this variable. But I have the address, so I don't want to use the constructor to paste. So this is the address you have to pass. Now let's come here. We have to, let me give this comment, say notice represent the deposit of an NFT. So we're going to follow some of the structure for the ERC71, and that's what we are inheriting from OpenZeppelin in our contract, because every liquidity will have a unique identity in our exchange. So we can easily able to identify, and that can be only possible when you are using the inherent properties of ERC20 tokens of like NFTs. So just follow along with me. That's what I have mentioned here. So let's define the struct. So we'll have a deposit, and in that we have to define that address honor. Then we have to define the UNT is a liquidity, the amount of liquidity we have provided. Then we have the address token 1, and this is going to be the token 1. So token 0 and token 1, because in that we're going to provide the liquidity. So that's, we have our struct. Let's close that one. Now let me give this comment dev deposit token ID deposit. So we have to create a mapping. Let's create a mapping. UNT, we can say deposit public deposit, because all the liquidity is going to be stored into this mapping. That's what we have here. Now let's come here. Let me give this command store token ID used in this example. So UNT public token ID, and that's because every time someone will provide the liquidity, this token ID will get increased. So when someone will provide the liquidity for the very first time, that person will assign ID1, ID2, or something like that. Okay, so we have the IDT. Let's define that implementing on ERC receiver, so that this contract can receive custody of ERC20 token, and that's the package we are getting from the OpenZipling, and that's what we are utilizing. So let's come here. We'll create a function on ERC20 receiver. We're going to add the address operator. We're going to add the address of, and we're going to add the address of the token ID, and we have to add this byte data, the data we want to provide. So call data external override returns, it's byte 4. Now let's come here. We have to create deposit, and in that we're going to pass this to data operator and token ID, and this function we're going to create. So it's going to be an internal function. Let's define the variable. So we have to return this dot receiver dot selector. Once we have that one, now let's come here and we have to create a function dot create deposit. It will have an owner, it will have the token ID internal, and we have to define a couple of variables. So let's provide this comma, and this is the structure we have got in the documentation of ERC20 token, and that's what you have to follow here. So we have to provide the address token 0, we have to provide the address token 1, we have to, the other one we have is this dot, then this we'll say UNT 128 liquidity, and this one is going to be comma, and this one will be have this one. Non-fungible position manager positions, and in that we have to pass the token ID. Let's give me this command set the owner and data for position. So for that what we can do is, let's operator is a message.sender. So whoever will call this function will call this deposit. In that we're going to pass this one token ID, and we have this struct, and now we have to update that. So we have this owner, and we have our liquidity is liquidity. We have to provide the token 1 first token, and this is going to be the second token. That looks pretty fine. Let's come here. So that's the come here, and we have to simply console log out the token ID so we can check that it's working or not. And now we have to simply pass out the liquidity so we can see what's the liquidity exactly we have got. So that's working fine. Now we have to simply take this token ID to token ID, and now we have to write the other function. So with that we are done with this function. So we have created the function which can create the liquidity, and now we have to write the function which can mint. So let's create that. So we'll say function mint new positions, and in that is going to be external. This will say return UNT token ID, UNT 128 liquidity, UNT amount, and this will become UNT amount 1. For this example we will provide equal amounts of liquidity in the both assets, and that's generally what happened in decentralized exchange. So when you will create the liquidity, you define a 50-50 ratio. So don't need to worry, we're going to talk about the concept that how you have to define the right liquidity so it can create good impact on your liquidity so you can earn more money from your liquidity which you provide on decentralized exchange. So we're going to talk about that concept. Just write the smart contract and everything will make sense when we'll connect this contract and do the swap in the real applications. Everything you will make sense. Just code along with me. If you have any confusion, any doubt, do just keep that for a time being. Just code along with me. So that's the asset we have. Let's keep this comment. Providing liquidity in both assets means liquidity will be earning fee and is so UNT amount to mint itna, that's the token, and that's the second one is going to be this much because we are doing with the wet to die. That's the amount we have. Let's approve the position manager. So we have this transfer helper, save, approve, and in that we have to simply pass the data. So we have to provide the die and we want to assign this non-fungible position manager and we have this amount. So we are transferring now. We have to simply use the transfer helper, save, approve, and in that we have to simply assign the data. So we have this USDC. Then we have to define the address, so non-fungible position manager, and now we have to define the simply the amount, so 1. So that's the safe transfer, approve. Let's come here, use the non-fungible position manager mint params, and in that we have to use this memory params and we have to define this non-fungible position manager mint params, and in that we have to define the entire object. So the thing we have to provide is token is going to be the die, and token second is going to be our USDC, and we have to define the fee. So we're going to take the exact fee of the pool fee we have defined. So that's the pool fee we have, and let's give this command by using this tick math mint and tick math max tick. So we are providing liquidity across the whole range of the pool. Again, it sounds complicated, but just follow along with me. Not recommended in production. Tick low is going to be tick max min tick. We have this tick upper tick max tick. So that's what we have here. Now we have to define the amount desirable, and this is the amount we have to pass. Amount 1 desired, and this one. Amount min is going to be 0. Amount 1 min is going to be 0. We have to provide the recipient, so it's going to be the address this. Deadline is going to block timestamp. Now let's do that. Note that the pool defined by die used. The reason why I have provided this comment that if you really want to know that what is the pool fee exactly happening in Uniswap. So if you visit the Uniswap pool section, in that you will find the range of the entire fee which you have to pay if you really want to do the swap from any token. So the current fee in the Uniswap exchange is from between DAI and USDT is 0.01%, and that's the exact fee we are defining here. Already be created and initialize in order to mint. So let's take this token ID, liquidity, amount 0, amount 1, and we call this non-position manager, non-fungible position manager, and we have to call this mint, and in that we have to pass the entire data which we have defined in the param. So that looks fine. Let me give this command, create a deposit. So we have to call this create deposit function. In that we have to pass the sender and the ID as well. So let's come here. Let me give this command, remove allowance and refund in both assets. So if amount is less and amount 0 to mint, so if amount 0 is less than amount 0 to mint, in that condition we want to simply call this transfer helper dot save approve, and we have to define this data. So the data we want to define is die, and the second one is going to be, let's say, address non-fungible position manager 0, and let's call the UNT refund 0, and we have to provide the amount minus this. Transfer, save, transfer, die, message.sender, and refund. If amount is 1 is less than, now we have to do the same thing whatever we have done with the first one, amount 1. Let's do that very quickly. Transfer helper dot save approve, and we have to simply approve it. So this time we're going to approve the USDC Now we have to simply approve the address. So address, this will become non-fungible position manager, and now we have to define the amount. So the amount is going to be the 0. Let's close this one, and now we have to call this function. Let's take a variable unt refund 1, because that's what we have done in the previous one, and we have to subtract it. Once we get that, we have to simply approve that. So save, transfer, and then we're going to pass this data. So that looks pretty good to me. So let's come here, close this one, and so that looks pretty fine. With this, we are end with this mint position function, which allow us to mint the liquidity into our decentralized exchange. Now let's write the function which allow us to get the liquidity fee, increase liquidity fee, or we can decrease the liquidity, we can remove the liquidity, all those functions. So let's write the first function is, let's call function, and we have to create this collect all fee. So whenever someone will do the transaction in our exchange, we have to get the fee. So all the fee is going to be stored in the contract, and we have to have a function which allow us to get the fee so we can take it out. So let's create the functions. We'll say external return, and we have to return this unt amount 0 and unt amount 1. That's what we have. Now we have to simply call set a max, and this call to 1 to unit collect all fee. So no matter what token they are swapping, so right now we are going with this 2 token hardcode value, but we're going to make it dynamic. So no matter what token, in generally, no matter what token they're going to swap, we're going to take the fee from all of them, and we're going to take it out with the help of this function collect all fee. And now let me give this current alternative can set receipt to message.sender and avoid another transaction. Let's come here, let's call this non-fungible position manager collect params, memory params, and we're going to simply pass the same non-fungible position manager collect, and in that we have to send the entire object. So the object we want to define is this 2 token id. That's the first one, and the second one we want to assign is this recipient is going to be the address, this the contract itself, and the third data we want to provide is this amount max is going to be this max value, and the second, third, fourth data you have to provide this 1, which is for the second token max. That looks pretty good. Now we have to assign, close this one, and come here. Now we have to make the transaction. So we'll say amount 1, and this is going to be the non-fungible position manager collect, and in that we're going to pass the params. So that's how we are making the transaction. Now let's console log out the fee. So amount 0. Let's do the same thing for the second one, console. And so with that, we are done with this function which allow us to collect the fee. Now let's write the second function. We'll say increase liquidity current. So this function will allow us to increase the liquidity. So what happened that in most of the exchange, suppose you have created your token, and at the initial time you have provided 50% liquidity, but later you found that the tokens are performing better and you want to provide more liquidity. So this is how you can do it with the help of this function. And again, I'm telling you these functions, these all methods I'm getting from the Uniswap documentations. So let's write the function from here. So I'll say range, and in that we have to set the couple of variables. So unt amount add, the number of token added, and we have to define the token other one. So let's make it external, and this will become return, and we want to return is the unt 180 and liquidity unt 256 token amount 0 and the amount 1. Transfer, save, transfer, and that we have to provide the token message.sender and the address and the amount add. Let's call the other save, transfer from USDC message.sender address and the 1 add 1. Once we're done with that, now here we're going to write the transfer dot save approve, so we can approve the contract. So die address non-fungible token position manager and the amount, and we have to call the same thing for the second function, sorry, second token. So position manager and the amount add 1. Once we're done with that, let's come here, we're going to call this non-fungible position manager increase liquidity params memory, and then that we're going to call this non-fungible position manager increase liquidity params, and in that we have to send the entire object which we have done already on top before. So we have to pass the token id, and we have to simply pass this amount increased, and we have to pass the second token amount 1. Let's define the min and do the same thing for the second token as well, amount 1 min 0. Let's provide the deadline block.timestamp, close this one, and here we're going to call that. So we'll say liquidity amount 10 amount 1, and we're going to call this non-fungible position manager, and then we're going to call this increase liquidity and provide the params. That looks fine to me. Let's come here, let's console log out this liquidity, and we have to simply console log out this amount 0, and the third one is going to be this dot amount 01 and amount 1. So that looks pretty fine. Close this one. And so with that, we are done with this function, which help us to increase the liquidity in existing liquidity. There is so many liquidity. I do understand that you guys are confused right this moment, but don't need to worry. Just be patient, work along with me, everything will make sense. The reason why I have decided to write the smart contract first, and later we're going to examine the entire contract, entire functions, that from where we are going and what exactly happening in the params and what this increased liquidity function are doing. We're going to examine each and everything in detail, and that's very important because when you will go in a decentralized exchange and create bots which can do the trade, so you have to know that what are the things goes into that to create a bot and automated tools which can do all the things for you. So with that, we are done with this function. Now let's write the other function. So let's come here, we'll call it function, and this function is going to be get liquidity. So if you want to know that how much liquidity you have provided in exchange, so for that we need to have functions, and that function we're going to create. So in that, we're going to pass this token ID external view, and it's going to return this unt, the amount of liquidity we have provided. So we have that one. Now what we can do is come here. So we have to define a couple of variables. So this is the general convention which you have to follow. So comma unt128 liquidity non-fungible position manager positions. In that, we have to pass the token ID, and now we have to simply return this liquidity. With this, we are done with this function get liquidity. All it does, it's provide you that how much liquidity you have provided in exchange. Now let's write the another functions which is called function, and we're going to call it decrease liquidity. So we have already written a function which allow us to increase the liquidity in the existing liquidity. Now what if you want to decrease the liquidity in the existing liquidity, and that's the function we're going to write. So in that, we have to provide the liquidity external return, and it's going to return the amount 1 and amount 2, sorry, amount 0 and amount 1. So by the name you can easily understand that what is this amount 1 and amount 1. It's going to represent your token. And let's come here, we're going to use this non-fungible position manager, decrease liquidity, memory, params, and we're going to use this non-fungible position manager and decrease liquidity params, and we have to send the entire object, the same thing what we have done above. So in that, we're going to provide this token ID, because that's how we can easily able to identify that what liquidity we are talking about, because exchange will have a lot of users, lot of liquidity providers who will create the liquidity, but every liquidity is going to be unique to a particular user. So that's token ID is the unique identification of every single liquidity. So we have that liquidity ID. Now we have to take the liquidity to liquidity, and we have to simply grab the amount 0 is going to be a 0, and amount 1 min is going to be the same 0. Let's come down here. We're going to define the deadline time, which is inside the block.timestamp. Let's close this one, and let's simply make the transaction. So amount 0, amount 1, and we're going to call this non-fungible position manager decrease liquidity, and we're going to pass the entire params. Once we're done that, we can simply console log out the data. So we want to have a look on 0, amount 0, and we want to have a look on the amount 1, amount 1. So that's the things we want to have a look. Close this one, close this one. And with that, we have done with all the functions and functionality for the smart contract. Now you can easily able to create liquidity, you can decrease liquidity, you can increase liquidity, you can get liquidity. We have written so many functions, and I believe that 80% of the code you guys haven't understood. you have coded along with me that you guys haven't understood, no need to worry. I was in the same state. I was confused when I had this contract and I looked at it, because DeFi is really very complicated thing. A lot of things goes into that, but I'm going to explain everything. Just code along with me and try to understand whatever I'm doing. So with this, we are done with this entire smart contract. Let's come up here, and if I come here, this is the function. So we have this license identifier, general convention. We are using all these packages, and we're going to have a detailed discussion on each of these packages. We're going to explore that what the codes are doing exactly, and why you should use this one, or why you can, and why you should use this one. And if you want to come up with your own, you can simply do the modification and create your own as per the requirement. We're going to talk about that as well. So that's what the here we have the contract name. We are inheriting the property of this 721. We have the two tokens which we want to swap, and this is the non-fungible position manager. This is the mapping we have. This is the first function. Simply close this one. This is the create deposit function which will run internally, and this is the mint position. This will create the liquidity, and this is the collect all fee. This will collect the fee, and this is going to be the increase liquidity. Close this one, pretty huge function. And now we have this get liquidity, which is a very simple function. Now we have this decrease liquidity. So we have written so many functions. This is the one, liquidity, increase current range, and that looks pretty good to me. So hope things are making sense again. And if you guys have encountered any error, I'll provide you the code in the starter file or in the complete code. From there you can get it. So that looks pretty fine to me. Now what we can do is, let's come here. With that, we are done with this entire smart contract for the liquidity, and that's the only thing I want to cover, because we have already written so many code and I don't want to make this video so huge, because most of you guys are complaining that the videos are getting huge, and that's why I try to make it shorter videos so you guys can get maximum in a small span of time. Okay, so let's move to the next video, and that we're going to do the testing of the contract which we have written. So let's move to that.